My name's Richard Douglas. I'm a senior lecturer here in the School of Geography and Environmental Sciences, and you're very welcome here at the Coleraine campus of Ulster University. So I'm just going to give you a bit of a flavour of the sorts of things we are teaching our environmental science and geography students and indeed our marine science students throughout their degree programmes here from the perspectives of me, a freshwater scientist. So here we have, our nice typical picture of Northern Ireland. We've got the cattle out grazing, looking out over our beautiful coastline, nice green fields, little bit of trees there in the background. So I'm going to show you how we try to get our students to take in what they are looking at in the environment. And we're very much about getting our students out and about and observing things in the environment. And hopefully by the end of the degree, they have a good understanding of what's going on. So as I've said, there's our three degree programs: environmental science, geography, and marine science. And I'm also course director of a MSc that we run here, environmental toxicology and pollution monitoring. We've been running that for the last 20 years or so. So there's our nice picture of our university building, our School of Geography and Environmental Sciences school building, and that was back in the snow, that heavy snow, 2010. So I'm going to, I've put up the details here of the biology specification for some of the things, which I hope as this presentation progresses, you will see how what we're teaching the students actually will have tied into what you may well have taught them already. And I'm specifically looking at the biology spec here. So we're looking at minerals, eutrophication, human activity and biodiversity, intensive farming methods, global warming, and the nitrogen cycle. So as you go through, hopefully you'll be able to relate to these topics. Oh yeah, that does tie in with that. And here we have our students. We take them down to County Fermanagh in second year, and they're building up their knowledge by then. So we're showing them real things out in the environment, and show how we have changed things and how things are changing in the environment and the effects that those may have. So what I tend to do with our first years, I'll put up a picture like this, and here, lovely picture in the Sperrins, and I'll ask them to say, well, if you'd been here 1,000 years ago, what would you be seeing there? And there'll be, weird and wonderful answers. But what I'm really trying to get them to realize is how we've changed things. So sometimes we talk about biodiversity, and we're very clear that we want to protect these uplands, and the peatlands, and we're from Northern Ireland here, and we know the importance of that sort of peatland, wetland landscape, and of course now with climate change and the release of carbon into our atmosphere, peatland really is a really, dense, good store of that carbon that's not getting released up in the environment. But let's not forget what that was like. So, here we have on the right hand side, that's the River Erne coming down into Lower Loch Erne. And here we have in County Down, the farmers getting the silage in, and then we've got the wind farms in the background, and of course looking down here on Belfast Loch. So what I'm trying to get them to think is 1,000 years ago, that was covered in trees. And that's hard for us all to really get our head around. And, sometimes, I'll work with colleagues, in some of the agencies and, people out and about, and we forget that. We forget what our environment was like. So, biodiversity, it's a difficult concept to actually define because, what is it that you're looking for to really increase biodiversity, and do you want biodiversity in your environment? And so take them through, after the last ice age, we're starting from a blank sheet again, and woodland started to spread, and we have our traditional trees that we have here in small numbers, but our birch, hazel, elm, oak, and alder. Then we, humans started having an influence. In 3,800 to 40 AD, half the land area was cleared by us, for agriculture, for, crops, for cattle, etc., etc. And then the Romans really, the spread of the Roman Empire, and they needed vast quantities of wood. So, by 1086, Doomsday Book shows we'd uncovered 15% of England. And indeed, now woodland cover in British Isles is currently around 7% for native tree species. So if we go back up here, British Isles were completely covered in forest, more or less, and now we're down to 7%. And of course, related to all that is these sorts of animals that we had running about. We had the wolves, we had the wild boar here, all the different sorts of animals and plants associated with that diverse forest cover. And we take our students out and show them evidence for that. So if anyone's done this walk down County Fermanagh, Stairway to Heaven, as it's called, Quilca Mountain, and you've got the wooden pathway all the way up, and it's a beautiful part of the world, and you're looking across this environment, which is pretty much just heathland, isn't it? That has been over the years, turf has been cut on that land, and it's produced a lot of energy from the point of view from the turf that's been taken off there. But you don't have to look very hard to see what it was like. And here we have remnants of oak trees, you know, um, thousands of years old. Some of these may well be, and you don't go far down into that soil horizon to find evidence of that. Um, and often say that, the sheep in these sort of highland areas, these upland areas, they're kind of, every day they're just nipping off buds, and nipping off, the potential for trees growing in that sort of environment. And it's a complicated story to try and make sense of. Is it better, leaving all that carbon well stored up in that peatland? Or would you take the next step and go, okay, these sort of areas above, say 1,000 meters, let's just let them go wild. Let the broadleaf trees come back. And to do that, it's a very difficult conversation. You're talking about getting rid of any sort of farming practice up there. Well, this sort of farm practice of sheep and those sorts of things, and indeed the National Trust and the Lake District in England, that's exactly what they're doing. They're fencing off vast areas because they're very wealthy landowners. They can afford to do that, and they're just letting nature get on with it. So those are very difficult conversations, and it's what we're trying to do is show our students um, the science behind these sorts of conversations. And here we have photosynthesis equation, and I'm sure the biology teachers among you are trying to get that into your students. But it's not hard really to see why we are affecting our climate, because we have our oil rigs, and what are they doing? They are taking carbon out of the ground. That carbon that has been locked away over millions of years, we're taking it out of the ground and we're putting it up into the atmosphere. So at that very simple level, um, it's not hard to see how we're having quite an effect. And of course, tied in with all of this is the human population. There's just so many of us now. Population growth here we have, sitting around, even the start of the 19th century or 1900 there, we're just heading towards 1 billion, and now we're heading towards 8 billion. Okay, so that's a huge increase. Think about all the vehicles on the road. What was the big thing in New York City in the early 1900s? What they were worried about? They were worried about horse poo in the streets. If the increase in population, there's going to be so many more horses. Well, suddenly the Henry Ford brought in the motor car, and things changed very radically. So the carbon that we're putting into the atmosphere, we're taking it out of the ground. It's going into the atmosphere, and here's your simplest set of data from the Mauna Loa Observatory in Hawaii, where they have been actually measuring carbon dioxide in the atmosphere, right out in the middle of the Pacific. And here's the data: carbon dioxide has gone up. Okay, so beside it, I have this picture of an oil well, because there's quite a link there. It's not hard to see. We're taking out carbon out of the ground in huge quantities. We're putting it into our vehicles. We're using it in our power plants, et cetera, et cetera, et cetera, and it's going up into the atmosphere. So that's what's going on there. So that's kind of looking at the biodiversity. Okay, I'm a freshwater scientist. I'm more interested, shall we say, in the the watery environment around us. And here's a very pretty picture looking out over Lower Lough Erne, and that's the Lough Erne Resort Hotel and the golf club that you have there. The Irish Open was there a few years ago, and here we have looking out over Lough Neagh. So we've a Lough Neagh's largest lake in the British Isles. Lough Erne's fourth biggest in Ireland. So we have more than our fair share of great freshwater environments. So are they polluted? Well, they are, and you don't have to look too far into our news headlines to see that we have a very serious problem going on. But this isn't news to a freshwater scientist. We've known about this for many, many years. And it's very difficult to get society, to get our politicians, to get full engagement with the very difficult problem that this is. I don't have any simple answers here, to help our freshwater environment, on the sort of scale that work needs to be done. None of this is simple. But the European Union brought out Water Framework Directive, and I remember I was involved with this, as a young researcher back in the late 90s. And, we were all quite excited by the Water Framework Directive. We thought, okay, wow, this is joined up thinking, and things are going to change. We're really going to get to grips with what's going on. And if we can see here, it set out rules to halt deterioration in the status of European Union water bodies and achieve good status for Europe's rivers, lakes, and groundwater by 2015. And you might be thinking, well, we've left the EU. What's happened to all that now? Well, after action in the EU, the directive was transposed into Northern law through the Water Environment Regulations 2017. So, Water Framework Directive is still completely applicable to us. That legislation that was brought in, the sort of approach that joined up thinking of, trying to get everyone involved in improving our water quality is still there. Yeah, even though we have left the EU. And the classification that we come up with, lake river status is classified in water bodies as high. So high is obviously very good classification, good, moderate, poor, bad. And how do we come up with those classes? They're established on the biological criteria of the water body, the chemical criteria, and the hydromorphological. Okay, so what's the catchment like? What's that lake basin like? And here we have more detail going through. So if it's bad, it's got severe difference from reference conditions. So back in the late 90s, part of my job was to go out to try and find lakes that were unimpacted, i.e. reference lakes, lakes that, had no discernible impact from us, from anthropogenic activity. And that was really hard to do. It was very hard to find unimpacted lakes here in Northern Ireland. Indeed, Europe-wide, that was a common problem because we've kind of affect them all, even way up high in catchments. So if we look at, Lower Lough Erne in County Fermanagh, beautiful part of the world, very important for tourism. And here we have 2020 data, and they split Lower Lough Erne into two sections because this is the deep part of the lake. It's about 64 meters there, and the deepest part, and then this is shallow part, and here we have the Erne coming down through Enniskillen and going into it, and then it leaves by there and heading towards the sea through Billeek and Ballyshannon. But if we look at the status in 2020 of this part of the lake, it was classified as poor, and here we have moderate. And this is not an improving story. That's the unfortunate thing about this. Though we've tried, and farming practices have changed, sewage treatment works, the legislation has changed. With the nitrates directive coming in, we've got farmers are only allowed to put out slurry during certain times of the year. We've got close season, etc. There's just so many factors, and we've been doing it for such a long time. If you think the Industrial Revolution, 1845, we really started get going with our fossil fuel combustion and population growth. We have a lot of years of pollution that has gone into our lakes. Okay, and we're getting these sorts of headlines. For the case of harmful blue-greens confirmed the shores of Loch Ness, for Manadog, vet warns of lake algae danger. And, we can get that any year. And I think it was, in the late 60s, 1969, there was from page of the Belfast Telegraph, there's an algal bloom. And on the back of that, Ulster University and indeed Queen's University, we had a research centre set up down in Ballyronan, looking at Loch Ness and Queen's, along with Department of Agriculture, had the same over on the far side of the loch on the eastern shore. So, scientists have been aware of this, and it isn't just specific to Northern Ireland. Lakes in the Republic, lakes, in England, Scotland, Wales, same sort of story, and very much so in the US. The Great Lakes in the US. A lot of our science has been informed by research that's gone on in the United States on the Great Lakes. And also Germany, France, Scandinavian lakes, New Zealand, a lot of the developed world, we know very well what is causing the problems. The problem is trying to get the complexity of those problems and, the very difficult things that would have to be done to fix them, trying to get make it economically feasible, making it that politicians can actually get a hold of this and get politicians to realize that, this is a long-term problem. You can't just think that this is going to get you votes the next election, that, we're looking at 20, 30, 40, 50 years strategies here to really try and turn the tide. So these sorts of headlines, we're going to get more of them. And, we're educating environmental scientists, geographers, heading out and into into their careers. So we're not backing away. We're showing them the difficulty of these problems and hopefully give them the education that they really understand these, so that whenever it's they're standing up in a meeting, that they're able to talk knowledgeably and have a really clear, sound understanding of what's going on. We've a lot of lakes here in Northern Ireland, and here's in the north and the south, lakes, and you can see in the western shores, we've loads of them in Connemara and Donegal, but all over border counties, we've got lots of lakes, and here's the size classes of them. So this is an important table, and it's a table that sometimes can get lost because the world's so busy and we're so busy trying to make sure our health system is correct, which of course is a fundamental thing. And we worry about, there's just so many problems in the world, isn't there? But what we try to show the students is where we've come from. If you're born in the last 20 years and you go out and look at your lakes, you go, well, that's the way that perhaps they always were. And maybe our grandparents can remember what a river was like 70, 80 years ago, but there's less and less people able to remember actually what those rivers and catchments and lakes were like. So here's a table looking at, so nutrients of concern. What I'm looking at here specifically is phosphorus, but we also have nitrogen. But for the purposes of what I'm going through here, we're looking at phosphorus. So phosphorus is a nutrient that's added to our land, and perhaps keen gardeners amongst us will put fertilizer on our lawns, and you can see when you put that fertilizer on, greens up lovely lush green grass. So farmers have been doing the exact same thing. After the Second World War, the onus really was on agriculture, got to produce more. And got to produce more grass, crops, more livestock, etc. So phosphorus was added to the land, and eventually that phosphorus will make its way, out of the fields, into the shucks, into rivers, and into our lakes, and everything slows down in our lakes, and that phosphorus slows down and drops down into that sediment, and can become available in the water column, be it from resuspension of that sediment go back into the water column, or just by the continuous drip, 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 or quite heavy flow of phosphorus into your lakes. So an oligotrophic lake is having the least amount of biological productivity. So if you just looked at least amount of biological productivity, you might think, well, that's not a great thing, is it? Well, actually, it is. Oligotrophic lakes, all our lakes, more or less were oligotrophic. They had very low amounts of nutrient in it, which was more than enough to keep a really healthy ecosystem going. The trout and salmon were able to lay their eggs in nice gravelly edges to the lakes or in the rivers, and there was more than enough nutrients in there. It was just being eroded from. You remember, phosphorus comes from rock, so it was being eroded from catchments. Going through the forest and making its way into um, rivers and lakes, and there was a simple balance there, and our lakes were healthy. Unfortunately, with various pictures in here. So, our detergents, we thought detergents were a big thing. We thought that was a huge source of phosphorus, and pressures put on companies to take the phosphorus out of the detergents, and they did that. And we still had nutrient enrichment problems. And then we thought it was our sewage treatment works. And, sewage treatment works have improved over the years, and septic tanks in houses have improved. But there is more and more developments going on, more and more houses, more and more people, greater pressure put in all of this. So you still get not, you do get raw sewage at times whenever something goes wrong, but you get treated sewage, and that treated sewage has very high levels of phosphorus. And then you've got farming. Farmers were told in the 1980s got to drain their land. They got lots of grants for that. Um, and actually, what that draining um, did in parts, it actually accelerated the process of getting the nutrients from the fields directly into the rivers and into our lakes. Um, and also, farmers were asked to, increase intensity. So our field margins, the hedges, the trees, etc., we had there were cleared. And of course, they had to get, dairy farming. You've got a lot of dairy cattle, you've got a lot of slurry, you've got a lot of manure, and there's no other option for it. It is a good fertilizer. It has to be put on the land. So all these things have come together to increase the phosphorus in our environment. So we've gone from oligotrophic. Mesotrophic is kind of mid-level, 10 to 20. This is your unit micrograms of phosphorus per liter. And then eutrophic, greater than 20 micrograms per liter. So that's from a textbook from the 1980s. That's how we defined it. Kind of in the mid 1980s, early 1990s, we brought in this term hypereutrophic because we were finding that there was concentrations way above this 20. So we had to get another classification. So that's the increased phosphorus into our land. So associated with that then is chlorophyll A. So whenever you add in more nutrients, more phosphorus, phytoplankton grow. Your blue-green algae grow. They need those nutrients to grow. And those all photosynthesize. And the biology teachers among you will know that photosynthesis, you need chlorophyll A. So a very simple way to measure the greenness, shall we say, of your water is to measure chlorophyll A. And we have these sorts of values for oligotrophic. It's not that green. And, as it becomes more nutrient enriched, you get more phytoplankton in there, starts messing, upsetting the ecological balance in there. Also, all those phytoplankton, as they grow, then whenever they die, they decompose, settle to the bottom of your lake, and becomes a black sludgy bit of a mess. We have this other reading here, Secchi disc, which is a very simple reading. It's just, a 20 centimeter wide metal plastic disc, or sorry, they're generally plastic discs now. They used to be metal, and it's covered white, colored white and black, and you put it over the side of your boat, and you keep looking at it until you can't see it anymore. Okay, so a lake that's very clear, you can see down to that water column 4 meters, and as it becomes more polluted, if we're relating that pollutant to chlorophyll A, that distance decreases. And somewhere like Loch Ness, I've seen it down to 80 centimeters, even lower, maybe 65 centimeters at times. That's as far as you can see through that water column. And associated with all this, it gets more complicated, because if you get a lot of this nutrient enrichment and the phytoplankton are photosynthesizing, they're using up oxygen, so you you would expect a lake to have plenty of oxygen, 80% saturation at least. But if you have a lot of phytoplankton growth, what that can do is use up that oxygen in your water column, which of course is disaster consequences for fish because they need that oxygen to survive. So you get these sorts of values. So I want you to remember the total phosphorus less than 10, which is oligotrophic. Okay, that's your you know, our 500,000 years ago type lake. And then you get these sorts of values. So I'm going to click on this. I'm just going to open up this spreadsheet, okay? So this is Northern Ireland Lake Survey from 10 years ago, okay? And so remember that total phosphorus value? Okay, we had 10 micrograms per liter was oligotrophic, and it was hypereutrophic, it was above 20. So here I've sorted out, if I go down to the bottom of the spreadsheet, we have a lot of lakes here in Northern Ireland, 615 lakes. Okay, now there's more than that, but in the sort of size classification we were looking at. So look at the values. Okay, so remember, if I can go back to my slide, oligotrophic, that's what we want our lakes to be, less than 10. If it's starting getting over 20 micrograms per liter of phosphorus, you're eutrophic. You've really changed that environment. And look at what our lakes are. You know, I have to go a long way down this. You're maybe seeing one or two lakes that you would know, and the various counties. And here we're getting into, you know, less than 30. Okay, not so many. So that's giving you an idea of, you know, of how bad things are, how much we have affected our environment. So it's, you know, I'm not giving you, unfortunately, I don't give our students a lot of good news, but I show them the reality of it, and there are solutions out there. You know, if everyone, you know, if you can get everyone around the table and get them talking about the scale of these problems, you know, really involve the farmers. You know, there's no point having radical solutions and then going to a farmer. Well, how can you implement that? And the farmers go, well, what's you want me to increase my output by 50%? Well, how am I going to survive? How do I pass this farm on to my family as a going concern? So, you know, we've got to work together. Everyone's got to work together on this, and that's what we're trying to get across to our students. That, you know, they've really got a vital part in all of this. Protecting and restoring Europe. If we look at this, protecting and restoring Europe's waters, analysis of the future development needs of the Water Framework Directive. You know, so 2015 is when we thought it was going to work. Then we just keep kicking it down the road. You know, 2027. Objective of good status or higher in all EU waters by 27 is a long way from being achieved in many countries, and I think you can see from that previous spreadsheet that Northern Ireland is no different. And don't think Northern Ireland is the worst offender. You know, let's not rank the countries, but you know, across Europe, across the developed world, we have been doing this. Some places, you know, are causes more issues because of the natural geology, because of the density of populations, etc., etc. But you know, this is by no means just a Northern Ireland problem, and we get this across to our students. This paper we published, my colleague Brian Rippey published this a few years ago, and this was showing recovery targets and timescales for Lough Neagh and other lakes. And if you can see this picture here, so what you'd be expecting to see at the bottom of the lake is nice fine gravel, generally nice fine gravel. And you know, any anglers amongst us will know that fish need that gravel to lay their eggs in. Okay, we've seen the nature programs, you know, we've seen the salmon jumping out, the grizzly bears in Canada. And if you look at those sort of freshwater environments, it's very clear water and this sort of an environment, clear gravel. Unfortunately, you take a sediment core from the bottom of Lough Neagh, and that's what the bottom of Lough Neagh looks like. And indeed, most of our lakes are like that. And that is really our phytoplankton over the years. As it decomposes, a bit like your, you know, your brown bin, um, or your compost heap at home. You know, as it decomposes, it turns black. That's what you're looking at here. And what Brian's paper here showed that actually, you know, if we really were able to do, you know, turn off the inputs to Lough Neagh. How long would it take to fix it? Well, with some complicated modelling, we came out with 8 to 20 years. Okay, so even if we stop the inputs overnight, it's going to take a long time for our lakes to get back to this sort of picture. So lots of difficult problems here for our students. So what about some solutions? Let's try and finish on a happy note in this presentation. Don't want you leaving Ulster University going, oh, we've got lots of problems here, and they didn't show us any solutions. How are our students going to engage with us? Well, we're just we're finished the project here. It was European funded project. We've got over 13 million euro. Various partners, and you can see Donegal County Council, Agri-Food and Biosciences, and Fisheries Ireland, Lochs Agency, Ulster University, Armagh City, Banbridge, Craigavon Borough Council, the British Geological Survey, and Geological Survey in Ireland. So within this, that huge amount of money, there are various projects going on, and some of them are involved with education, primary schools, getting them out and about into catchments. And what we did here at Ulster, or one part of what we did here at Ulster with this project, was look at some ways that you might be able to use chemicals to decrease phosphorus in catchments. And that kind of goes against environmental thinking, doesn't it? That we're going to add another chemical to stop this phosphorus. And I agree with that. I know if you have any concerns with that, understand where you're coming from. But hopefully you'll see here, this was small scale, what we're looking at, and this is not a fix. The fix has to be sorting out the inputs into our freshwater environment. But this can be useful in certain areas, certain small lakes, maybe, lakes associated with, parks, golf clubs, those sorts of places where you want a nice, clear, for aesthetic purposes, you want a nice, clear lake. So here we look at another set of data. So 224 lakes monitored by the Irish Environmental Protection Agency, and there's a cluster with poor and moderate water quality status along the border regions. You can see along here. So we've got a brown and yellow, those are poor water quality. And that's from nutrient enrichment, from those sources that talked about sewage treatment works, agriculture, developments, forest clearance, all those sorts of things are causing these issues. So we assessed the feasibility and transferability of using chemical salts to remove phosphorus from the water column, locking it away into the sediment to increase the lake's ecological status. So your drinking water every day gets a chemical added into it, aluminium sulfate, and it's perfectly safe, been used for decades upon decades. And what it does is here, very simple picture, so here you have water that's, looks quite sediment rich. You add in ferroalumina sulfate, aluminium sulfate, and it combines with the particulates, forms precipitate, which is heavy with gravity. Then that settles out of the water column. So the overlying water is extremely clean, and then you have any of those sediments, the aluminium sulfate precipitates and settles them out. And that's used on a daily basis by water companies across the world. Water companies use extensive processes to make sure our water quality is good, and they do a great job of that. And this is one of the things they can use. So we agreed to try and do this on some small lakes in border catchments here in north and south, namely in Monaghan and Tyrone. We looked at lakes. So we had people around the table, and to try and get approval to add these chemicals to these small lakes. And it was interesting to see how different bodies have a different interpretation. So, I'm a freshwater scientist. I'm passionate about the freshwater environment. I want to improve things, but I'm under no illusions how difficult it is. And it was interesting to see how different departments have a different look. So, they may be looking at lakes in their catchments that they're responsible for, and they don't want them touched because they think, well, we've got to protect this environment. But actually, most of the lakes are in extremely bad condition. Okay, they're very polluted, they're very eutrophic, they're really nutrient enriched. So doing a project like this was difficult because we were asking, various agencies, can we add this chemical? So after a lot of negotiations, it was agreed that we could do this at a very small scale, which was completely correct, and the amount of chemicals we added was very small, and we went through a very clear process of deciding what lakes we could add aluminium sulfate to. And the first thing was the lake in a state, was it nutrient enriched? So the cutoff we had was 50 micrograms per liter. Okay, the amount of phosphorus in that lake had to be over 50. It had to be really nutrient enriched, heading to the hypereutrophic status, and it had to have very chlorophyll A value. So that wasn't hard to find. So we did that. Then the next thing, this is where this technique, you need to be very careful with it, because if you're adding in aluminium sulfate, that can make your water become very acidic, which can cause a knock-on effect of a whole lot of other problems. Very acidic water can release a lot of chemicals that are already in that sediment, pollutants that have been stored there over the last 150 years, that are locked up in that sediment, but you've suddenly got acidic water above it that can get released back up into the water column. So adding aluminium sulfate will increase the acidity by a known amount. So we had to make sure that those lakes were of a specific alkalinity, that by adding in our known amount of aluminium sulfate, we weren't going to make these lakes acidic. So again, that ruled out a lot of lakes. Only certain lakes, depending on the surrounding catchment, the surrounding geology, had alkalinity suitable for this sort of restoration. Then, of course, cost came into it. Huge lakes, close to the like of Loch Ness. Can you imagine doing that and the amount of chemical you need? And apart from all the other issues, so lake area, lake depth. So we wanted to do this on manageable lakes. It was a new technique. Boat access, we needed to do it off a pretty decent sized boat. So we needed some sort of slipway, or if not a slipway, some good way of launching and retrieving our boat, because basically we were putting a large tank on that boat, filling it full with aluminium sulfate, and using a pump to traverse that lake, to pump it into that water column, to cause the precipitation to remove the overlying nutrients. And of course, then lake use. We had to be very understand that, was this used a lot for leisure activities? Were angling clubs using this lake? All those knock-on effects. So we came up with 3 lakes that we did that on: Grove, Grea, and Corcahan, all in County Monaghan. And you can see they're all small and not too deep either. 3 meters, 2 meters, 2 meters kind of average depth. So these are small, shallow lakes. Okay, and remember, here's our oligotrophic lakes. That's what we're aiming for, less than 10 micrograms per liter, and this is what the phosphorus was in these lakes to start with. So this was unfortunately in the middle of COVID. So we'd lots of problems, to get out and field work. We'd lots of issues, but we managed it. We had to travel separately, and stay in different ends of our boats whenever we were out in the lakes, etc. But we were able to do it. And there's our various lakes. You can see the sort of catchments. Look at this typical, farmland, and then you've got your little lake, in the middle of this, intensive agriculture type area, typical sort of Northern Ireland, Southern Ireland type picture, isn't it? So we dosed our lakes. So here we can see some of the things. Here we have our tank on the boat. And here we had a trailer with our chemical, and we pumped it into our boat, and then we had another pump on the boat. And as we traversed the lake, we did a lot of experiments with this, just with water, to make sure our flow rate was correct. And then we just went up and down our lake like this and put a known amount of aluminium sulfate. And of course, we measured before we did it, for months, indeed, up to 2 years before. We measured all these variables, and we did fish surveys before. We got environmental consultants in to take fish, and we measured the aluminium in those fish, and we measured it in after the event. So we dosed sort of October 21 to March 22 over the winter months. Here's some pictures of us out doing it, small boats, very difficult catchments to manage, trying to retrieve a boat out of there, very mucky. Remember I was saying about these sort of gravel areas, not much gravel going on in these lakes here. You can see the farmland just going straight down onto it. And that was us adding our chemicals. And I've got some nice drone footage that really puts in perspective, shows how we went up and down our lakes, and how the chemical precipitated right away. And did it work? Okay, that's the question, and that's the question that people are wanting answered. Well, of course, with science, it did to a certain extent, and we didn't expect this to, this has been done before. It hasn't been done before in Ireland, but it's been done around the world before. It's been done a lot in the States. It's been done in New Zealand. It's been done in Germany. Been done in Scandinavia, and it does work. It's quite simple chemistry. Precipitates, takes it out. But if your inputs continue, very quickly you're back to square one. So, we're early stages of this, and we can see two things here. Did chlorophyll A come down? You can see chlorophyll A came down very quickly. Did aluminium levels, we added aluminium sulfate, did those levels, get really high? Well, they got high around dosing time, and then they came back down to, these are very low values anyway, and we dose with very low values of aluminium. But so far, it has worked. Whether it's a long-term fix, yeah, I wouldn't be so sure. But it certainly has use for certain, be it for local councils trying to keep ponds clean, golf clubs, etc. But how does that tie into what our teach students? Well, here's some of the projects that we've had them doing on that. Acute toxicity of aluminium sulfate to Gamma stubini. So that's this little shrimp. That's, find this everywhere, all the water bodies around Northern Ireland. So what I wanted to do was see, okay, we've added this aluminium sulfate. Lots of the agencies were worried about this doing it, even though there is detailed toxicity studies done on this worldwide. But I wanted to do it in a local species. So we got students to do their dissertation on this. And we got some really interesting results that really backed up that, really these gammas, the concentrations that we were using was nowhere near concentrations that would cause them any problem in their natural environment. And we had students looking at the pre and post, looking at the results that we got them going out, taking water samples, looking at concentrations of phosphorus before dosing and after dosing. And then, associated with this project, monitoring of these lakes is expensive and difficult. And we wanted to see how drone technology, whether that could be used, to actually save money, to mean that we could get, much more detailed monitoring data so that you could see the effects of, any sorts of, improvements that we're trying to do to rivers, lakes. So I have a PhD student now working through that using a drone, and he's taking water samples from lakes, and hopefully that's going to be really useful to, government agencies that maybe are thinking of using this technology, to help them with the monitoring demands that are put on them. So I hope you find that useful. Just play this last video. This is just a few images from our second year field trip with environmental science students when we had them down in Lough Erne. So hopefully this runs okay for you in our PowerPoint. Let's see.